Hi, I'm Rich with insideHPC. We're here at SC15 in Austin, Texas, and we're here at the ARM booth, and I'm here with Jason and Eric. Gentlemen, how are you doing today?
Yeah, pretty good.
Excellent. Good. Jason, let's start with you. What is ARM showcasing at SC15?
So the big thing for this year is we're showcasing ARM's software ecosystem for HPC. Right? So we've been coming to SC for a few years now. And my team was brought in to look at the software ecosystem for ARM, for the HPC. And what we've been doing is we've been talking to a lot of sort of partners and customers to find out what the big sort of gaps are in the ecosystem. One of the major things that was identified was a good Fortran, a good commercially supported Fortran compiler. Right? So one of the things that's been announced this year is Pathscale's commercial EKOPath compiler. So that's a C, C++, and Fortran compiler. So that's been announced to production this year.
So that'll help you get the applications for the broader ecosystem. What's the state of that right now?
So the ARM ecosystem is growing. I think this is now our 4th year at supercomputing. I was actually brought in 3 years ago after spending 12 years at IBM Research working on HPC by ARM to help ARM address the high-performance computing market as a broader part of our server strategy. So the ARM ecosystem is made up of a number of companies. We don't actually build physical things. We're an IP company, and we sell that IP to partners, right? And so we have a number of silicon partners that are, in fact, here, like the likes of Applied Micro and Broadcom and Cavium, that have been building very high-end servers and starting to target both the high-performance computing and the data analytics market. Now, and those guys are, of course, sell to system integrators who then wrap those up into larger systems. And some of those system integrators have software stacks and others do not. And so part of the ecosystem engagement has been to engage with a number of ISVs like Pathscale into providing commercially supported libraries, as well as working on open source support for math libraries and compilers and tool chains and so forth. I lead the research effort, and we've been actually working on a contract with the DOE as part of the Fast Forward program, together with Broadcom and Cray, to help explore node designs based on the ARM architecture for exascale. So it's absolutely something that ARM as a company is dedicated to, meaning the HPC market.
And what advantages does ARM bring? I know it's good for low power consumption, but what other things are attractive to those folks?
So I think one of the best things that we bring to any market segment, but in something that's been particularly lacking in high-performance computing lately is sort of flexibility, right? So we have this IP business model and that we produce a bunch of Lego blocks that people can put together in all sorts of different configurations, and that's how we get the power efficiency. The power efficiency isn't magic Cambridge pixie dust. It's actually the ability to design the system for the workload. That's where you get the efficiency out of. And that's what the ARM IP-based business model brings. The other thing that it brings with that is a great diversity, right? So it's not just like there's an ARM chip that's going to be targeted at HPC. I just named 3 partners that are here that are competitors. And so what it does is it keeps this very vital ecosystem where it's same architecture, same software ecosystem, but you've got competing partners, and what normally they all find their own niche target area, but they're all iterating quickly to compete with each other as well as the other architectural competitors that we have. And so it brings a lot of vitality back. Back when I started in high performance computing, there was about a dozen different HPC system integrators, large-scale system integrators, with at least 10 different architectures underneath it, and we're down to a handful. And one of the reasons I joined ARM was this opportunity to bring diversity back into high-performance computing, to get the ecosystem that's hardware and software much more vital.
Yeah, no, I was going to ask you, I mean, what's been the reception from, you got these software writers, right? And it's like, is that all they need is another hardware platform to support? Or are they actively like, no, we want to come to get, what are you hearing?
The reception has been amazing. Yeah. I mean, really awesome. So I mean, this year we had a user group, our first user group for the software ecosystem. We had a packed out room. We had 4 hours of guest speakers. Everyone stayed till the end, which kind of blew me away. we got some amazing feedback. So I mean, one great example, the STFC Hartree is a research centre in the UK. They were given a £19 million grant to research low-power supercomputing. Okay, now that's a great showcase because they had Lenovo provide them with Cavium-based systems. And in fact, the Pathscale Compiler was a great enabler for that. And so those guys right now are doing some great sort of science into low power. And those guys were there, they were telling their story, and it was a really good reception.